All right, let's talk about something pretty complex: psychoactive drugs. We're going to go from ancient rituals all the way to modern medicine, from one single patient's agonizing choice to the digital chatter of literally millions of people. It's clear these substances pose some of the biggest challenges in science and, well, society. So let's dive right into this tangled world of brain chemistry, ethics, and, believe it or not, big data. So, what if your tweets could help find the next dangerous drug side effect? I mean, it sounds like something straight out of sci-fi, right? But this question, it's at the very heart of a new frontier in public health research. We're going to explore how all those unfiltered posts on social media are becoming this absolutely crucial real-time source for figuring out what really happens when people use these substances. But before we get to all that futuristic stuff, we've got to look back. I mean, way back. Our relationship with mind-altering substances, it isn't new at all. In fact, it's pretty much as old as human culture itself. So let's take a quick trip through time.
So, way back in ancient times, you had hunter-gatherer societies using things like psilocybin mushrooms, magic mushrooms, and mescaline from cacti, mostly in spiritual rituals. Then farming comes along and boom, you get opium, cannabis, and of course alcohol. But the science behind all this, that's way more recent. The word psychopharmacology doesn't even show up until around 1920, and the modern era really kicks off in the 1950s. This is huge because for the first time we had drugs like lithium for mania and chlorpromazine for psychoses. This was a total game changer, a massive shift from just, sedating people to actually trying to provide targeted treatment.
Okay, so we've made this incredible leap from spiritual ceremonies to precise medications. But what are these drugs actually doing up there? How does a little pill completely change someone's mood, their thoughts, even their behavior? Let's get into the nitty-gritty. So this all comes down to one field: psychopharmacology. It's a fancy word, but all it really means is the scientific study of how drugs affect our mind, our mood, sensations, thinking, all of it. And the key thing to get here is that it's not magic. It's just chemistry. It's a series of very specific chemical reactions that literally alter how our brain communicates with itself. Okay, picture your brain, right? It's like this super complex, high-speed communication network. Your neurons are constantly firing off little chemical messages to each other. We call those neurotransmitters. Now, a psychoactive drug comes along, and it's basically like a hacker getting into that system. It messes with the process. Maybe it blocks the message from being cleaned up, so it just keeps firing. Or maybe it pretends to be one of the messages, tricking the system. Or it could just stop the messages from being sent at all. Whatever it does, the result is the same. The brain's communication gets fundamentally rewired, and that's what we feel as an altered state of mind. So, understanding the science is one thing, right? But actually using these powerful drugs in the real world? Well, that's where things get messy. And I mean really complicated. So let's step away from the textbook and into a real-life clinic with a case that shows the kind of impossible ethical choices doctors are up against every single day. And this quote, it just nails the central problem. Doctors live by two main rules. First, they have to try and help people to relieve suffering. That's called beneficence. But second, and just as important, is the idea of first do no harm. That's non-maleficence. Now, when you're dealing with really powerful psychoactive drugs, these two core duties can start to pull a doctor in completely opposite directions. So let's meet Mr. R. He's a 71-year-old man, and he's got advanced Alzheimer's disease. At this point, the disease is causing severe agitation and aggression. It's obviously incredibly distressing for him, but it's also becoming almost impossible for his family to care for him. And here's where the problem starts. His wife, Mrs. R, is his power of attorney. She's the one making the decisions, and she is dead set against using any psychotropic medication. She's seen the warnings, she's heard the horror stories about side effects, and she's terrified. So she absolutely refuses. Then the whole situation it escalates, tragically. During one of these agitated episodes, Mr. R actually injures his daughter, breaking her wrist while she was trying to help. So now the decision not to medicate has resulted in real physical harm to someone else. This isn't a theoretical debate anymore. It's a crisis. And you can just feel the impossible position the medical team is in. On one hand, their job is to help Mr. R to ease his suffering and to protect his family from getting hurt again. That's that beneficence principle. But on the other hand, they have to respect the wife's decision. That's patient autonomy. And they know these drugs have serious risks. Those FDA black box warnings are no joke. That's the do no harm part. There is absolutely no easy answer here, no perfect choice. So look how incredibly difficult it is to figure out what's right for just one person. Now, imagine trying to understand these effects across millions of people. How in the world can we get a real picture of both the good and the bad on that kind of scale? Well, this is where our story takes a hard turn into a totally new and kind of radical approach. So, 92,291. What is that? Well, that's the number of tweets in a groundbreaking new data set. See, instead of waiting for slow, formal clinical reports, researchers did something different. They went out and gathered over 92,000 tweets where people were just talking. Raw, unfiltered personal experiences, the good and the bad, with drugs like ecstasy, GHB, and 2CB. And this just shows you the insane scale of this whole thing. This is not some small, controlled study. That heat map shows where they collected the data from, an initial pool of over 5 million tweets from all over the world. This gives them this huge, immediate snapshot of what's happening. They can spot trends in real time, something that traditional methods, which can take months or even years, could never, ever do. Okay, but having millions of tweets is one thing. Making any sense of them? That's a whole other challenge. I mean, how do you turn all that slang, all the typos, all that casual chatter into actual reliable data? Well, let's get into the methods, because they basically had to build a machine to find the signal in all that noise. And this right here, this is the secret sauce. This is how they did it. First, they grab all the tweets using keywords and slang terms. Then comes this really clever part they call weak supervision. So instead of paying people to read and label thousands and thousands of tweets, they just gave the computer some cheat sheets. They fed it lists of words like amazing and awesome for positive experiences, and terrible or sick for negative ones. This left them automatically create this massive labeled dataset, which they then used to train a proper AI model to spot these patterns all on its own. But they hit a pretty major snag. It turns out people are way, way more likely to jump online and tweet about a bad drug experience than a good one. So over 95% of their data was labeled negative. Now, for an AI model, that is a huge problem, because it can just learn to guess negative every single time, and it'll be right 95% of the time, without actually learning a thing. So how'd they fix this? Well, they tried a few advanced tricks, and this chart kind of shows what worked. The higher the bar, the better the model performed. The one on the left is the baseline, what they started with. The winner is the one in the middle, using a technique called cost-sensitive learning. Basically, this just tells the AI, hey, listen up. Those positive tweets are rare, so if you miss one, it's a much bigger penalty. You need to pay extra special attention to them. And as you can see, that little nudge worked. The bar is a bit higher, meaning the model got better at spotting both the good and the bad experiences. And all of this brings us right back to where we started. But now that question feels a lot heavier, doesn't it? This kind of technology is an unbelievable tool for public health officials, for doctors. It's a way to watch for danger signs in real time. But it also opens up some massive questions about privacy, about surveillance. The more we live our lives online, the blurrier that line gets between a public conversation and our private health data. And that leaves us with the big final question. Who should be listening in, and what should they be allowed to do with what they hear? That's something we're all going to have to figure out.